So once again, in today's topic, we shall be once again continuing with another important topic, that is your suspension. Apart from the topic that we have discussed so far regarding solution, we have described what a solution is, and we also saw as what are the properties of solution. Now, as we told that there we shall be looking into the subcategories of this homogeneous and heterogeneous mixture. Now we shall be describing regarding suspension, what a suspension is. A suspension is a heterogeneous mixture whereby the solute particles do not get uniformly dissolved within the solvent. As like that of solution, what we saw that the solid particles get uniformly dissolved within the solvent. In solution, what we got that the solute particles get uniformly dissolved within the solvent. But in case of suspension, the solute particles do not get uniformly dissolved within the solvent, and as a result they remain suspended through the bulk of the medium. All right, for your understanding, let me tell you, as in case of solution, we took a 1 glass of water and 1 teaspoon of sugar, and thus we saw that the sugar got uniformly dissolved within the solution. But in case of suspension, let me take 1 glass of water and 1 teaspoon of flour, say maybe atta or maida, something like that. You take 1 teaspoon of flour, mix it over there, all right, mix it over there nicely, and ultimately what do you get? You will find that the flour particles remains through the bulk of the medium. More or even you go on stirring completely, at one go you will be looking at the water has become completely milky somewhere. That means the particles have nowhere got uniformly dissolved within the water, rather has turned the water milky. That means the particles are still present within the bulk of the medium. It has not got occupied in between the spaces of the water. Why? It is because of the reason that the particles of suspension, where in a suspension the solid particles are much bigger as compared to the solution. So this is something exactly opposite to that of the solution. What you got in case of the solution, it is something bit different than that of the solution. This suspension is completely opposite to that of the solution. So thus this makes a clear-cut difference in between solution and suspension, that a solution is a homogeneous mixture whereby the solid particles get uniformly dissolved within the solution, and in case of suspension, when we are talking about suspension, that suspension is a heterogeneous mixture. This is the thing that you need to understand, heterogeneous mixture. A suspension is a heterogeneous mixture whereby the solid particles do not get uniformly dissolved within the solvent and they remain within the bulk of the medium. So this is the basic difference between solution and suspension. Probably you have got the idea as what is called as suspension. So now let us look into some of the properties of suspension. What are the properties of suspension? Number one, I'm reading it out so that you can understand with the lining. The letters have become slightly smaller due to the area of the board. I'm sorry for that, but anyways, just try to follow as what I am telling. A suspension is a heterogeneous mixture. This is the number one property, that a suspension is a heterogeneous. It is not a homogeneous mixture. Suspension is a heterogeneous mixture. This is the thing that once again you need to burn in your mind, as you have borne in your mind regarding solution, that a solution is a homogeneous mixture. Now in case of suspension, a suspension is a heterogeneous mixture. All right, that means the solid particle will not get uniformly dissolved within the solvent. Number two, the particles of solute are bigger enough to be seen with naked eyes. That means in case of suspension, the solid particles are quite bigger, that they do not occupy the spaces in between the particles of water or maybe within the solvent. That means the space in between the solvent particles is quite smaller as compared to the solid particles. That means the size of the solid particles is quite bigger to occupy the spaces in between the solvent particles. All right, therefore the particles remain suspended within the bulk of the medium and can be seen easily with naked eyes. All right, now as they are seen with naked eyes, the third point becomes obviously possible, that whenever we will be scattering a beam of light, the particles will be seen very easily, because the particles we are able to see with our naked eyes. So whenever we will be passing the light, obviously it will become much more clear for us, and thus the particles can be seen within the ray of the light. That is what is meant as thus making the path visible. That means it becomes very much visible for us to see the particles of solute within the solvent in a suspension. And lastly, they can be separated from process by the process of filtration. That means the particles are so big that the solid particles will stick on to the filter paper, and they will not allow the particles to come throughout through the solution. As in case of solution, we have seen when we have tried to mix up the sugar within the water, the sugar particles got uniformly dissolved within the water, and even after passing through the filter paper also, they got clearly passed out, and the sweetness of the water remained the same. But since the particles of the suspension the solid particles of the suspension is quite bigger, so they get stuck up within the filter paper, and thus they can be separated by the process of filtration. So these are the properties of suspension. Let us reiterate once again. A suspension is a heterogeneous mixture. All right. Number 2, the particles of a solute are bigger enough to be seen with naked eyes. They scatter a beam of light, making the path visible. They can be separated by the process of filtration. So today, basically, with the two topics that we have discussed regarding the solution and suspension, you go through it, try to understand this. Next day, we will be coming up with a new video regarding colloidal solution. Till then, stay tuned. Thank you.